Then let's start. We had a little bit delay because we have a Windows laptop.
That's not the issue.
So welcome to our talk, build and run your own intelligent application based on open source using Semantic Kernel and Kaito. Before we talk about the technical things, just some introduction for us. So my name is Philip. I'm a senior platform and Kubernetes engineer. In my spare time, I work at White Duck. My major time, I have kids and I'm a husband. So when I have time, then I do some stuff. Martin. And I have Martin with me today here. So,
hello, everyone. My name is Martin. I'm working at the company White Duck as a CTO and cloud solution architect. And there I'm helping customers developing cloud-native applications. I'm looking forward to present the semantic kernel to you in a few minutes.
OK, then let's get started. Agenda for the talk. Let's want to talk shortly about intelligent applications, that we are just on the same page. Then I will do some introduction to Kaito. Then Martin will talk about semantic kernel. And then we will have a demo. So I think everything is included. OK, intelligent applications, there's no real definition for that. So we can tell you whatever we want. But basically, what our thinking about is an intelligent application leverages AI services to perform tasks and making decisions, to do everything automatically what a human would do before. So you leverage the AI service commonly or mostly over the REST API in the model as a service approach. And the big players are there, OpenAI, ChatGPT, Google Gemini. These are sort of like the common approaches how you would consume a large language model as a service. But sometimes you want to have the large language model, the model closer to your data, or in your own facilities somewhere. And there's the question how we would do this. And as we are on Kubernetes Community Days, the obvious answer would be Kubernetes. So we can also run our models in Kubernetes. But why we want to do that, we can leverage our existing infrastructure, what we have. Most of you maybe have a Kubernetes, so we can just use it and extend it. And we have existing knowledge. So all of us are Kubernetes experts, I hope, or want to be. So we can leverage all these thingies to run our model in Kubernetes. As I mentioned before, we have the network and data security. So our clusters, for example, in our on-premise facilities, we can run our there. We can run it on the cloud in a private environment. So just to do some isolation of these data. We have support for open source models. So it's also the last slide. So the model as a service approach can be open source, but it's not fully. You don't know how the model is trained and which parameters. So it can be a black box also if OpenAI says it's open source. And that's why you have the support for this open source models, or you can also bring your own. I think open source models, if you know Hugging Face, is a famous hub for open source models. So yeah, this is the reasons why we run it in Kubernetes. OK, then we have Kaito. Kaito is the RE toolchain operator. It's open source completely. You can have it managed when you're running on Azure. So you make a CI command and Azure will install it for you and manage it. Or you can use the Helm charts and make a standalone installation. The big approach, or the approach of Kaito is it manages LLMs in container images. So you have pre-trained models, and they are container images. You just run it in Kubernetes. And it also eliminates with presets, the amount that we tune our GPUs or everything for the model. So you have presets with Kaito, and you apply those presets, and everything is like you want it. So you don't have to tune everything. That's the idea behind it. And what also takes care is provision the GPU nodes for us. So, what's the architecture of Kaito? Basically, it's the operator pattern. So we just apply a YAML, and everything will be working for us. So we are here the operator. We apply the workspace CRD, which is the workspace controller. It will reconcile our workspace. And it also takes care and leverages the node provisioner, which is basically Carpenter under the hood. And Carpenter, then, or the node provisioner, will provision our GPU nodes, and the workspace will take care of the AI workload. Do I have something like? Here. This AI. Yeah. So what's the benefit also of Kaito is, as I said, we can bring our own models. We can use the public registry from Microsoft, for example, and there the open source models are, let's say, living or stored. We can apply those, and then the workspace pull those images and runs the model. We can also go here with the private registry, so we can apply our own images, which we tuned or whatsoever. Kaito comes with this model support, so we have open source models like Falcon, Llama 2, Llama 2 Chat, Mistral, Phi 2, and Phi 3 is coming now or soon. And this is basically the 12 lines is the only thing you apply with Kaito to the cluster. So it's the workspace CID. It says which the preset says which VM this model needs. Carpenter takes care of provisioning those models on this VM, and we have just the preset Falcon 7B, which means the Falcon open source model is trained with 7 billion parameters, and then we are good to go. Excuse me. If you don't find your model, what you want to run on this list, what you can also do is you can make a proposal to the Kaito team, and if they agree on a proposal, they will set up a new preset, and you can apply the YAML. You can use any of those here and apply it from your own registry. But if you have a model which is not supported by the Kaito controller, it will be rejected from a validation webhook. So you can use your own preset and your own model. And what you also can do is you can leverage the workspace API and apply, for example, the Falcon model, and you can use the parameter efficient fine tuning and tune those models and then output it again to your registry, and then you can run it again. Basically, the parameter efficient fine tuning is like Falcon has 7 billion parameters, and to retrain all the 7 billion parameters is like really costly and take a long time, so you can just tune those parameters you need, and not all, and you will have a cost-efficient customized model, let's say. That's the idea. Okay. And what we don't show in the demo later, we have a Kubernetes cluster with Kaito running, obviously, and we have the Falcon 7B model running there, and we exposed it via Ingress externally. That's basically the setup for the demo. And now, Martin.
Thank you, Phil. I don't
take
think
over.
Needed. Okay, let's talk about semantic kernel. In the next 20 minutes, I will try to give you an overview what is semantic kernel, how it works, and why you should use it. And finally, I also have a small demo for you. This doesn't work. No, it works. Okay. So semantic kernel is an open source SDK that was initially developed by Microsoft, and it is intended to help developers to build cloud-native applications. Intelligent applications. So unlike Kaito, the semantic kernel project targets mainly software developers. Microsoft itself thinks about the semantic kernel as the central component of an agent or AI stack. And in fact, many of the Microsoft co-pilots out there are based on the semantic kernel project. So why should we need such things, such like a semantic kernel? Why would we not just call REST endpoints to consume our models? For me, it's a very important requirement that we are able to switch the models within our intelligent applications, because there are many models out there, and we probably want to see which fits the best to our requirements. And also, the new models that will come out in the future are probably way better than the one that exists right now. And most of the time, they're also cheaper and faster. So it's a really key requirement that we are able to switch the models without changing too much code. And semantic kernel is basically such kind of library that allows us to do that. So semantic kernel supports large language models like Azure OpenAI and Hugging Face, but we can also write our own connectors to connect whatever language model we want to use. And the project is available currently for C#, Java, and Python. All right. To understand how semantic kernel works, all we need to know are 3 entities. The first 2 I will cover on this slide, and the last one I will cover with the next slide. So the first thing we need to know is that there are something that is called a connector. And with a connector, I'm able to connect or integrate any third-party services, like a large language model, but also something like a vector database to add memory capabilities to our application. And then the next entity we need to know are the plugins. And this is basically the main component when working with semantic kernel. Everything we create or define that we will do with plugins. So we can either use existing plugins. For example, if we need to invoke an HTTP endpoint, there is an HTTP plugin available for us, so we do not need to write it ourselves. But most of the time, we are, when working with the semantic kernel, we will create our own plugins to add some kind of functionality. And there are two different types of plugins. There are the native functions, where we just write normal native code, for example, C# or Java code or Python code. And we usually use the native functions for things where we do not need an AI, or for things that a large language model can't do for us. For example, if we host this application on a server and we want to get access to the file system, then we won't be able to do that with a large language model that is hosted anywhere else. For that, we need the native functions. And then we have the second types of plugins that's called prompts. Previously, they called it semantic functions and or semantic plugins. And there we do not write native code in C# or something like that, but we're writing prompts, as the name suggests. So we use natural language to define what we want to do. And of course, this prompt is then sent to a large language model using a connector, and we will get the result back. And the last entity you need to know when working with semantic kernel is the planner. The planner is an orchestrator for our plugins, and it allows or it enables us to invoke the plugins, let's say, automatically. So here is where the magic happens, I always say, because we do not tell the semantic kernel how to invoke which plugin in which order, but semantic kernel will figure that out itself and try to optimize it also. So that's why I say it may increase the cost, because running the planner involves also AI and a large language model in the back, but it might also improve your plan and improve the call sequence, for example. Okay, I would say let's see how this looks in action. I have prepared two demos for you. One will connect to the Falcon model, which is hosted on the Kaito cluster, which Philip set up. And then I will have another demo to demonstrate that we can just reuse the same plugins with a different model, this time with Azure OpenAI. And the results, I will spoil, are much better, and we can do a little bit more with it. But let's see how this looks like. Okay. We close that. I hope you can see it. I can increase it if not. Yeah. Okay. We'll come to that later. The link seems to not work. Okay, we will check that. Okay, let's start with the Kaito demo. So in order to use the semantic kernel, all we need to do is we need to install a package from pylpy.org. So this time I use Python as the environment, and we can do that with pip install. I have already done this, so I do not need to run it again. And then we will import the kernel object from the semantic kernel package that we have just installed, and the Kaito text completion connector. So as of now, there is no Kaito connector out there, so we have written our own. Due to the limited time, I will not be able to show it to you in detail, but you can have a look at it in the GitHub repository as soon as we fix the link there. All right, but so we have implemented our own connector here. And we just need to specify here two things. I think it's a little bit, increase it. It's the AI model we want to use, in this example, Kython with the Falcon 7b instruct model. And we need to specify the URL, the endpoint. So this is basically the cluster IP and the endpoint where the Kaito is hosted. Then we initialize a new kernel object, and we pass the connector to the kernel. And this is basically the setup of the connector. And if you remember, the second important entity we need to work with or to know are the plugins. And here we add all plugins that are in the plugins folder. And let's quickly jump there to see that. Oops. So here we have a plugins folder, and we have two prompt plugins. And let's have a look at the first one, kubectl prompt. So here we have a config, and I also have to toggle word wrap, I think, with a description. So the description is necessary so that the kernel knows what this plugin does. In this case, it turns natural language into kubectl commands, like a kubectl copilot. And then we have input variables. In this case, we just need a text input that should be converted to a kubectl command. And then we have the prompt, so it's just normal text, and I don't know why I have to do it again. But the prompt is write kubectl commands to solve given problem, always answer with a kubectl command, never provide any explanations, only commands are allowed. So I specified this twice, and then we put in the input there. So pretty simple. And now let's check. I have not run this before. Oh, and also this one, I think I need to run. Yeah. Let's do that again. Okay, and now we run the prompt. With the input, list all namespaces. And the result is disappointing in my opinion. Okay, I tried it many times. This time is not that fault, but we also get explanations, and we got much more than we requested. So if I execute it again, sometimes the output is very weird, but it's not related to semantic kernel, but it's related to the Falcon model we use behind it. So I will show you the same demo now in a few minutes with Azure OpenAI, and the results are much better. Phil, what's up with your cluster? I think I should turn that off before, but
I think it's your code. It's always the code.
Yeah.
It's never the cluster.
It worked on my machine.
It worked
But
before.
it worked before.
Yeah. It just looks like a network issue. So usually it doesn't take more than a second. Okay, let's try it again. At least it runs once, so you believe it.
You are not playing a live demo which you pre-recorded.
Thank you. Yeah. Okay, let's see what's going on there in a second. Okay, now we got the result. And as you can see, it should not contain any descriptions. Yeah, it's not that good, I would say. And the second plugin I've wrote is a plugin that tells us whether Kubernetes is a good match for a software project. Let's see how this looks like. So the description is determine whether Kubernetes is an appropriate platform for the specified project. Then we pass in a project description. The prompt is a little bit longer. I basically asked them to assess whether this is a good fit, Kubernetes is a good fit, and we also added some factors to consider, so to improve the output. But let's try how the output is. So I have two demos, one with a good fit description. It's a high traffic e-commerce platform with high scaling availability requirements. The team is experienced in containerizations. The architecture is based on microservices, so it should be a good fit on Kubernetes. But I can tell you, the Falcon model sometimes tell me to not use it.
I don't see the fit for Kubernetes.
You don't? Okay, let's see. It also takes way longer than with Azure OpenAI, but it might be also the network here. Let's see. All right, so based on description, Kubernetes might not be a suitable choice for the given project, so I highly disagree.
I told you so.
And but again, this is not related to semantic kernel, it's the model behind it. And this is a good sample, in my opinion, to show how important it is to be able to switch the model without changing much code. So let's switch the model now. So now we go to the Azure OpenAI model. We're using the Azure OpenAI ChatGPT model. It's GPT-4o to be exact. And let's go up. So again, we need to initialize the kernel. This time we are adding the Azure Chat Completion connector. The connection string for that are located in the environment file. I've provided you a description on top. Then we add the plugins directory, the same as before. and then we run the list all namespace command, and I expect the output less than a second. Yes. kubectl get namespace, so this works way better, and I tried it, I think, 20 times, and I always get the correct result back. All right. Then, I don't know why I hit this. Let's see how the good fit project, how the Azure OpenAI assessed this project definition. But in my experience, based on the provided description, the factors considered, Kubernetes appears to be a highly suitable platform. So this looks way better. And also, remember we described some factors to consider, and it gave us an answer why this is a good fit for each factor we wrote there. So way better output than the Falcon model. And also the bad fit, based on the right description and the factors to consider, here's an assessment of the Kubernetes. Let's see, on the bottom. The summary, Kubernetes is not suitable for this project, and simpler deployment solutions should be considered. So way better output for the same code, but with a different model. And the next thing I want to show you, or the last thing, is right now we just covered the prompt type of plugins. We will now add a native plugin. And this native plugin is just a few lines of code that allows us to execute kubectl commands using Python. So we just run that here. Again, we need to add this plugin to the kernel, and then I will try to execute this command using kubectl cluster info as the input string. And we now should get the output of the cluster that is hosting the Kaito model right now, or the FICO model with Kython. Okay, so this works. And as you can see, we invoke all this using semantic kernel, but we also specified exactly which plugin we want to use. And now let's have a look at the planner. And as I mentioned, this is where the magic happens, because I just create a new planner object, and I ask them a question or instruction, and my instruction is list all namespaces. So I do not tell him to look up what is the command for it, or that he can execute it. I will just write list all namespaces. And let's see what the planner does with it. And I hope he does the right thing. Crossing. I have a typo. That's even better, because that happens in real life too, right? But thank you, yeah, namespaces. Okay, it takes some time. But yeah, what we see here are the namespaces from Philip's cluster, even with a typo, you're correct. And we can also do things like
Delete all namespaces.
delete all, create a KCD demo namespace in the Kubernetes cluster, and we try it again. Namespace KCD demo created. Yeah, so
Jetzt musst du auch nochmal List-Namespace machen.
nochmal List Namespace to improve it.
Nicht, dass du da das einfach ausgibst.
Now let's try.
Ah, da war das Echo.
It takes a little bit longer because he needs to create the plan first, but for some reason he did it twice. Do we see the KCD demo? 33 seconds, so I hope this is proof enough. And we can now also print the plan, so we can inspect what the semantic kernel created for our instruction or question list all namespaces. So you are in the process of helping the user, blah, blah, blah. This is the prompt for it. To achieve the goal of listing all namespaces in a Kubernetes cluster, we can follow these steps. Use the kubectl prompt function to generate the appropriate kubectl command to list all namespaces, and then use the execute kubectl function to execute the generate kubectl command. So this was nothing I taught the semantic kernel, but it figured it out itself using the planner. And this is for me really exciting, that we are able with, I don't know, 50 lines of code to write something that is able to control the Kubernetes cluster with just natural language. Yeah. Okay.
Solve all problems.
Hopefully. No, I doubt, but I think it's a nice demo to showcase what we are able to do right now, right? With just a few lines of code. Yeah?
Can you ask him to bring any secret?
I can do, to be honest, we tried it before, and for whatever reason it does not work, but let's try it. List all secrets maybe first.
Maybe he's so smart that he doesn't list secrets.
Maybe he protects us for you. Yeah,
Yeah.
that's that might be the case. I should add a namespace maybe, right? So as you can see, I don't have an output here, and I don't know why. Let's see. Oops. Or maybe we do it like this. We ask first, we check what's the right command for that. Secrets, from here is in the default namespace. kubectl, that's right?
Yes.
Let's try. But for some reason, we have tried it before, and with secrets it does not work. I can't tell you why. I don't get an output, but we can do.
You can do pods.
List all pods in the was war der Falcon namespace. So this should work. I can tell you why it does not work. We had to have a look at the plan maybe.
Are there any safeguards? So
And here it is. No, at least I have not configured one. Maybe ChatGPT. That might be the solution that the output gets filtered by ChatGPT. Yeah, that could be. Really good point.
do you have secrets to this?
Did you do?
Do you have any secrets you can list?
That's another. Philip, you set up this cluster.
I don't know. It's a platform. It's a service. So.
Wait.
No, I don't know. I think there's a secret in the namespace.
But we can also try delete the KCD.
You can list secrets in the workspace namespace. There's a secret.
Secret is where in the?
Workspace namespace.
Okay, let's try that. But let's quickly try to delete the KCD demo namespace. And as you can see, it doesn't matter how I write namespace. The model is able to figure it out correctly, and he deleted it. Okay, so last try. List secrets in the
Workspace namespace.
Thank you. Oh,
You're right.
maybe we had no output, yeah, before. I don't know. Okay, so it's not bulletproof.
Not yet.
We still need platform engineers, it looks like. Phil, you can keep your job. Yeah. That's all. Thank you very much.
Do you have a last word before Martin cancels us? Kaito is open source. It's a very young project. You see the models, they are open source, but they are maybe OpenAI has better quality, but you can train a model and run it on your own. So it's just a possibility that you can run it in Kubernetes. The model still decides how good it is, the answer is.
Okay, it's still private. We need to get it public. Yeah, we will fix it.
Okay, any questions?
So is the Kaito only work for the Azure or?
At the moment, as it only works for Azure, yes. But it's the architecture is like this. Whenever you can run Carpenter, you can run it. But the presets, the workspace controllers are only for Azure at the moment. But it's open source, so everybody can contribute, and then it will change, hopefully. Yep.
The basic question is how you interacted with the prompt. Is this how, like, prompt engineers, is this like a popular way to people just are in VS Code and like a mix? I don't know how the workload, how people are using it.
Yeah, I'm not an absolute expert. We have one in our company. So there is, if you use Semantic Kernel with Visual Studio Code, you have a playground where you can execute prompts. So usually we use this to improve it before we implement it with Semantic Kernel itself. I would just try it. Zen mode. Maybe I can show it to you. I'm in the Python environment. There, it's not. No, I'm in the AI environment. We should see it here. Semantic kernel. Genau, and here also, this is really cool thing because these plugins are basically the plugins we are implemented in Python or in the project, and we can run it here natively. I have to sign in here, but I can invoke the plugins even without a Python notebook or anything. I just need the plain text here, and then I can run the prompts. But there are way better tools for prompt engineering out there. It's like for me as dev, this is sufficient enough. All right.
Okay. Any more questions? If not, so we also next to the coffee machine we have our booth. So we are now at the booth, so you can come and ask questions if you want. Thanks.
Thank you.